Alright, so solving trig equations. The first example here, 2 sine theta equals 1, you need to divide both sides by 2, and then you'll get sine theta equals half. Now our domain is theta is in between 0 and 2 pi. So in which quadrants is theta equal to positive half? Now remember, all stations to central, it means we're looking for the first two quadrants. So in the first quadrant, our acute angle or our related angle, sine 30 degrees is half, but because the domain is in radians, it means you have to give your answer in radians. So 30 degrees is pi on 6. And then our angle in the second quadrant, over here, is going to be pi minus pi on 6. Okay, so that means our two angles are going to be pi on 6. And then over here, to work out what the other angle is, you can find a common denominator. And then you can see the answer is going to be 6 pi minus 1 pi, which is 5 pi. And leaving the denominator the same, it's going to be 5 pi and 6. So there's our two solutions for the trig equation 2 sine theta equals 1. If you had an equation like this, tan theta equals negative 1, then in which quadrants is tan negative? And tan is negative in this quadrant, in the second quadrant and the fourth quadrant. So first you need to work out what the related angle is. So the related angle is going to be 45 degrees because you know tan 45 equals 1. And 45 degrees is pi on 4. So you can say the related angle is pi on 4. So that means our theta is going to be pi minus pi on 4. That'll be our angle in the second quadrant. And down here it's 2 pi minus pi on 4. So finding our common denominators there and there, timesing that by 4, that becomes an 8. You end up with 4 pi minus 1 pi is 3 pi. And 8 pi minus 1 pi is 7 pi. So there's our two angles where tan theta equals negative 1. Okay. 4 cos squared theta equals 3. So let's first divide both sides by 4. And we'll get cos squared theta equals 3 on 4. Then we'll take the square root of both sides. So we'll get cos theta equals plus or minus. It's easy to forget that plus or minus. Root 3 on 2. Squaring the numerator, squaring the denominator. Now that plus or minus means that we have angles in all 4 quadrants because cos theta is plus or minus in positive or negative in all 4 quadrants. So in the first quadrant, our theta is going to be, so thinking about your exact values, cos of one angle equals root 3 on 2. Well, you know that sine 60 is root 3 on 2, and sine 60 is equal to cos 30. That's going to be 30 degrees, which is pi on 6. Oh, sorry, pi. So let's rub it out. Out for some reason, I'll just scribble it out. So our answer was pi on 6. That's in the first quadrant. In our second quadrant, it's pi minus pi on 6. In the third quadrant, it's pi plus pi on 6. And in the fourth quadrant, it's 2 pi minus pi on 6. So our answers are going to be pi on 6 in the second quadrant. Let's find a common denominator there of 6, and you can see that's going to be 5 pi on 6. In the third quadrant, we're going to end up with 7 pi on 6. And in the fourth quadrant, change that to a 6, times that by 6, you get 12 pi. Oh, that's cool. So you will get 12 pi minus 1 pi is 11 pi on 6. So there's our 4 solutions. So the indicator that you got 4 solutions is when you've got a question with a squared in it. got to take that plus or minus, which gives you all 4 quadrants, so 4 solutions. Okay, if you have a question like this, 2 sine theta equals cos theta. Now remember, sine theta divided by sine theta over cos theta is tan theta. So what we can do is say divide both sides by 2 and divide both sides by cos theta. So what we're really going to do is divide both sides by 2 cos theta all in the one move, all in the one line of working. So on the left hand side, 2's cancel and you're left with tan theta. And on the right hand side you're left with half, because the cos thetas cancel. Okay, now tan theta equals half. Let's see, which quadrants is tan theta positive? And it is positive in the first quadrant and the third quadrant. Now, there is no angle, there is no exact angle. We learnt the exact values for 30 degrees, 45 and 60 degrees. And tan of none of those angles equals a half. So to work this one out, we're going to have to press inverse tan half or shift tan half on our calculator. And that equals 0.46 radians. Remember, our domain is in radians, from 0 to 2 pi radians to 2 decimal places. And then our other angle in the third quadrant here is going to be pi plus 0.46. Okay, so our two angles, I guess, to 2 decimal place would be 0.46 and 3.61 to 2 decimal places. Another example, sec theta equals 2. Now sec, remember the third letter rule, is 1 on cos. So 1 on cos theta equals 2. That means timesing both sides by cos theta and dividing both sides by 2, you get cos theta equals half. Positive half. So cos is positive in the first and the fourth quadrant, or stations 2 central. Half is one of our exact values there. Remember, sine 30 is a half, so cos 60 is a half, and 60 is pi on 3 radians. So there's our angle in the first quadrant, and in the fourth quadrant then it's going to be 2 pi minus pi on 3. So our angles are going to be pi on 3, and finding a common denominator there changes that to a 6. 6 minus 1 is 5 pi on 3. So there's our two angles. Last example. Sine 2 theta equals root 3 on 2. Now remember, our original domain was theta is in between or equal to 0 and 2 pi radians. Now when you have an equation with 2 theta, that means you have to change this domain. So now 2 theta is in between 0 and 4 pi radians. You might remember this from prelim when we changed it, when the original domain was from 0 and 360 degrees, and we changed it then between 0 and 720 degrees. Very similar. So that means we're going to be going around the unit circle twice. Okay, so sine 2 theta equals root 3 on 2. So that means 2 theta equals, so sine of what angles equals root 3 on 2? Well, you know sine of 60, which is pi on 3. Okay, and what other quadrant is sine positive root 3 on 2? And sine is positive in those first two quadrants, so in the second quadrant here it's going to be pi minus pi on 3. Alright. And we'll just work out what those two angles are. So that's pi on 3, and changing that to a 3, that to a 3, that will be 2 pi on 3. Now remember, our change domain here means we want to go around the unit circle another 2 pi. So just say pi on 3 is here. So that's pi on 3 radians. We want to go around the circle again. From there we want to add another 2 pi. So that other angle is going to be 2 pi plus pi on 3. And likewise, in our second quadrant there, we had our 2 pi on 3 was that angle there. That was from the positive direction of the x-axis going around there. That's 2 pi on 3. And we want to add another 2 pi. So that's going to be 2 pi plus our 2 pi on 3. That will give us our 4 angles. So let's just work out what they are first. So we've got pi on 3, 2 pi on 3, we've got a common denominator, changing that to a 6, 7 pi on 3, changing that to a 6, 7, 8 pi on 3. Now that is what 2 theta equals. We want to find what theta equals. To find what theta equals, we have to divide all of our answers by 2. So, pi on 3 divided by 2 becomes, I'll show you what that working out is like just as an aside down here. Pi on 3 divided by 2 means you're doing pi on 3 times by the reciprocal. So you can see that's pi on 6. So that first angle there is going to be pi on 6. And if you were to convert these angles to degrees, pi on 3 is 60 degrees. 60 degrees divided by 2 is 30 degrees, which is pi on 6. Okay, we're dividing this 2 pi on 3. We're going to divide that by 2 as well. So 2 pi on 3, obviously, when you divide by 2, the 2 is going to cancel, so you're just going to be left with pi on 3. And next angle, 7 pi on 3 divided by 2 is going to be 7 pi on 6. Similar working out to what we had here. When you're dividing by 2, you're timesing by the reciprocal. And we've also got 8 pi on 3 divided by 2, which becomes 8 pi on 6. And that can be simplified to dividing both by 2, 4 pi on 3. So our fourth angle is 4 pi on 3.